Hello and welcome to the first week's lecture on applied business statistics. I know that most of you may not like math and you may not like or nor enjoy listening to lectures and classes that involve a lot of numbers. Um, to be honest, I also did not like statistics in my undergraduate years. I never enjoyed it. It was very confusing for me. It was very complicated for me, so I never enjoyed it. Not until I went on and pursued graduate studies and conducted and worked with great professors when it comes to research, that I realized the value and the importance of statistics. Um, and numbers do not lie. Numbers will give you the best um, the best backup to your claims. It will give you the best reasons to believe and to hold on to something. So it makes you feel confident and feel it makes you believe that what you are saying or what you believe in is correct because of the numbers that statistics will show you. So hopefully, this class, I will be able to help you realize the value and the importance of statistics. And I am also hoping that you will fall in love with statistics as I did. Um, Especially if you are really looking into uh, getting into the business. And this class will hopefully make you realize that business statistics, will help you come up with sound and good decisions, and it will definitely help your business to progress. So let me go straight to the importance of business statistics. Number one, decision making. You cannot just make decisions for your business um, by gut or by feelings or by emotions. Um, Business involves a lot of investments, not just financial investments. You invested time, you invested effort, you invest a lot of things when you set up a business. So, because you are very much invested in setting up a business, you will also want for it to succeed. So you just do not make decisions based on how you feel, what you think is right, what others say is right, but you want to rely on a very good basis for your decisions. And for you to come up with sound decisions is you look at the numbers. Because again, numbers do not lie. So you look at the data. So business statistics provides a framework for analyzing data, identifying patterns, and making informed decisions based on objective evidence. Okay? It helps you mitigate risk and optimize business operations. So for example, um, you want to set up a French restaurant um, in a Muslim community. Okay. Now, what are the common French cuisine? Okay, you have beef, chicken, a lot of vegetables, okay, which is good because if you're going to look at the numbers, how many Muslims eat vegetables? How many Muslims eat salad? How many Muslims eat lamb? How many Muslims eat beef? How many Muslims eat chicken? So, looking at the numbers, then you can say, okay, my restaurant has a higher chances of success if I operate it in the Muslim area. Now, because you want it to be organic and you want your raw materials in your restaurant to be organic, to create a special kick or a special or uniqueness in your restaurant. Now, the prices of organic raw materials to create delicious food is quite pricey. So it's very expensive. So now you look at the numbers again. The Muslim people in the community who will be my customers because I am opening my restaurant in this area, what I will do a distribution. I will do a statistics count, like how many of them are earning above average, how many of them are earning average, and how many of them are earning below the average. Because if more than 50% of the people in the community are earning below the average income, then what are the success or what are the chances of my restaurant to succeed? What's the success rate of my restaurant? If I am going to offer organic meat and organic vegetables to make my restaurant, my French restaurant, unique, do I get a higher chances of success when if I know that 50% of the people in the community are living or earning below the average income? No, of course not. So, should I continue with a restaurant? If I do, should I get rid of the idea of organic raw materials, organic recipes, organic ingredients? Should I just go for the ordinary ones, which is cheaper? Maybe that will be that. So again, the decisions that you make to set up the restaurant, what raw materials or what ingredients you put in that restaurant, what food you serve in the restaurant will have to depend on the numbers. Okay. Now, number two, business statistics will also help you understand market trends. Okay. By analyzing historical and current numbers or market data, business can gain insights into consumer preferences, competitor strategies, and industry trends. This knowledge is essential for developing an effective marketing campaign or pricing strategies and product development plans. Okay, so for example, if you notice that the population of this town, so let's look at the population, let's look at the population statistics. You realize that for every one man or for every one male, there are two females. So that means there's more female in this town. Okay. Now, now you also search like what are the females? Are they married? Are they single? Because that means if you have more females than male, then you might as well set up a business or start a business that would interest the females, because that means there's if there are more females, then that means the population is more, that means you have more customers. Instead of setting up a business that would only concern the men, then that means you're only targeting a fewer market, a very small amount of the market. But if you want to target both men and women, and I mean, if you want to set up a business that would get the attention of the bigger population, then that means you need to set up a business um, that would that will be useful for both men and women, but it would be more appealing. It would get the attention more of the women because the women in that area has a bigger population. There are more women compared to men. So let's just say you realize, okay, I'm going to do a business about shampoo because both men and women use shampoo. Both men and women take a bath and or take a shower and they use shampoo to clean their hair. But of course, my shampoo would have a very nice scent because if I want to get the attention of the bigger market or the bigger population or more customers, then that means I will have to get the attention of the women. And women likes to use shampoo that smells good, not just the shampoo that cleanses the hair or the shampoo that makes the hair softer, but also a shampoo that smells good. So I'm gonna use that nice scented shampoo as my business. The question now is that what's the trend? Like with these women, what is the price range that they usually buy when it comes to shampoo? Do they spend more than $20 of their money a month for shampoo, or is it just between $10 and $12? Because if that is the case, then that means I will have to make my shampoo within that price range. Okay. And to be able to sell my shampoo within that price range, I will have to reconsider the ingredients, the raw materials that I will use for my shampoo. that it should not be very expensive. It should be low cost so that I can sell it within the price range that women in this community are buying. But at the same time, it has to be smelling good. It has to work as a shampoo where it can clean and make the hair softer. Okay. Now, what's the trend? Like, when do women buy the shampoos? Most women, they buy the shampoos at the end of the month. So that means if I need to make a production, I don't need to make a lot on the first 2 weeks of the month, but I will have to make sure that I will have to make a lot on the third and fourth week, because that is the time, the fourth week is the time that women usually buy the shampoos. Okay. So now you understand how the market buys, you understand the price range that the market wants, you understand what the market wants and what the market needs because of statistics. And lastly, improving operational efficiency. So, statistical methods can be applied to analyze production process, inventory levels, and supply chain management. So that means you will be able, again, that's what I've said. When it comes to production processes, do I need to produce more on the first week of the month, or do I need to produce a lot by the end of the month? Okay. So let's just say, for example, if I have 10 staff who makes these shampoo, one staff can make 10 shampoos in 8 hours. So that means every day, if they work every day, I can have 100 shampoos every day. Okay. Now, every end of the month, when these women buy the shampoos, I usually sell 500 to 600 shampoos by the end of the month when they start doing their grocery shopping for shampoos at the end of the month. So if I have 10 staff and every staff works only for 8 hours, and within the 8 hour shift they make 10 shampoos each, so that means I make 100 shampoos per day for 30 days. That means 100 times 30, it's like what? 3,000 bottles of shampoo. I make 3,000 bottles of shampoo. However, I'm only selling 500 to 600 bottles at the end of the month. So that means I have an extra 2,400 that I can resell in the next month. And if I sell 600 again, that means I have an extra 1,800 that I can resell next month. So technically, you will be able to find out, oh my God, I do not need 10 staff. I only need probably 4 staff, because 40 times 10, 400, 400, 800, 1, 2. That's even more than enough that what I need to sell. Because if I'm only selling 500 to 600 bottles by every end of the month, then that means I do not need 10 people to work for me. That's just additional cost for my company. I'm paying salary to these people. They make products, but the products that they make are not selling efficiently. They will be sold for a very, very long time. That means I will have to store these extra products that are not sold, these extra shampoos that are not sold. I will have to store them. Do I have space in my business? If I don't have a space, I am going to rent a warehouse where I can store them safely. That's another cost. So now you can evaluate, okay, hang on, if for 1 month I can make 3,000 bottles of shampoo, but I'm only selling 500 to 600 bottles every month, that means the 1 month production can already supply for the next 6 months. Should I stop the production and tell these people to come back on the fourth month or third month to produce for another 6 months? It depends on how you going to do it. Or should I just stop the production, leave probably only 2 staff to keep on producing for the next months? Okay, so the numbers, statistics will help you decide whether you need to hire more staff, lessen your staff, whether you need to hire or rent a warehouse to store your products, and how many products you have left that you can still sell next month? Do you have a safety net just in case some of your staff don't come to work? Do you still have extra products? Because for example, if you have two staff, that makes 10 bottles each, so you make 20 bottles each for 30 days. That's 600. That's just the enough bottles that you sell. What if one of the staff gets sick and she was absent for 3 days? That means you lost 30 bottles in the production. You only have 570 bottles left. Now, how can you cover up the 30 bottles that are missing to supply by the end of the month? Well, you checked your inventory. And again, statistics will help you with that. Okay. Now, the scope of business statistics, there's two. There's a descriptive one, which summarizes or presenting data in meaningful ways. It measures like the mean, median, and standard deviation and the variance. It helps understand the central tendency and the variability of data. So this is the easier statistics. This is the most common statistics. Like for example, if you want to do a survey of people as to which channel they want to watch. If you want to do a survey, what time do they watch TV? In that way, you will know when you are going to put your advertisement, okay? Because, you know, even deciding to advertise your product on TV, you need statistics because you need to understand. You don't want to pay the television company to post an advertisement on your product between 2 a.m. to 5 a.m. Who's watching it? Nobody's watching it. So you want to do a survey. How many people are watching TV, and then what time do they usually watch the TV? What is the highest number of viewers? What time do you get a highest number of viewers? Which show gets a lot of viewers? Because you don't want to advertise your product in a show where only 20 people are watching. So you want to advertise your product in the prime show that a lot of people are watching. So you're going to conduct a survey. Now, descriptive statistics is what survey is all about. Okay. You want to know the mean, the median, the standard deviation, and the variance. So I will explain that later into details. What is the mean? What is the median? What is the standard deviation? What is the variance? And how each of these represent what each of these words represent, and how can you come up with a good business decision with the numbers that they represent. But that's what we call descriptive statistics. So it's just like very easy describing you the information, just giving you the basic information of something. Okay. Now, the more complicated one is what we call the inferential statistics. Okay. Inferential statistic deals with drawing conclusions about a population based on a sample data. Okay. So that means the population is too big. Let's just say, for example, you want to know how many Filipino men want to marry a foreigner woman. Okay. Now, the population of the Philippines is 110 million. Let's just say, for example, 48% of that population are men. So that means roughly you have 50 million Filipinos are men. You cannot interview all the 50 million Filipinos. You do not have time, you do not have the resources, and you cannot force all of them to join your survey or your interview, right? So instead of interviewing all of them, you're just going to get a sample, like a size that can represent the entirety of the Filipino man. Okay? So that is why when we do inferential statistics, I will explain that to you later. We also have what we call as a margin of error. Okay, a margin of error, it means it's normal that there is a little margin of error because you do not get the responses or the feedback of all the people that is involved. You are just getting a sample, a small group that can that their opinion might represent the whole group. Okay, so it involves hypothesis, it involves testing, it involves confidence intervals. Oh my God, you might think, Professor, what are these words? Statistical modeling to make predictions and generalizations. But again, do not worry about the words. Do not worry about the jargons or these specialized words in statistics, but I will explain them to you later, one by one. In that way, you will be able to understand what they mean, okay, and what they represent, and how are they important in understanding your market, your population, in understanding the business in general, and how you can come up with a good decision using these numbers. Okay. So now let's go to the type of business data. Okay. The business data, these are the information. Okay, when you say data, it means information. These information will now be either a descriptive statistics, okay, the information that is a result of a descriptive statistics, or an information that came out as a result of your inferential statistics. Okay, now quantitative data. Quantitative, that means quantity. So that means it involves numbers. Okay, quantitative data involves numerical values that can be measured, that can be analyzed. Okay, so for example, you can say, out of the 10 people that I interviewed, 9 of them likes to use Colgate toothpaste. Okay, now you have a numerical value. You have a quantitative data. So what are you going to do? Let's go to descriptive statistics. Very simple. Okay, very simple. You will have question number 1. What kind of toothpaste do you like to use? A. Colgate. B. Pepsodent. C. Sensodyne. D. What's that? The other one. Crystal. Okay. So you give this question to 10 people. Okay. And then the 10 people will check. They will just check whatever toothpaste they want to use. And then you get the answers of the 10 people. Now, you look at 8 of the 10 people that you asked that question, tick the box Colgate. So that means 8 of them like to use Colgate. 2 of them like to use a different brand of toothpaste. So there you go. You did a descriptive statistics, a very simple statistics. And that statistics gave you a quantitative data. It gave you a numerical value. It gave you a numerical result, numbers, that 8 out of 10 that you interviewed likes to use Colgate. Okay, now qualitative data, this is different from quantitative, so it now goes for quality. So therefore, it doesn't describe numbers, okay? But instead, it asked for characteristics, opinions, perceptions, okay, like how the people view the products. Okay, so now let's just say, for example, um, it may include numbers too, but the numbers there are not very, very important. It's more of the quality or the description. So let's go back to your survey question, your descriptive statistics. Now, your question is, what kind of toothpaste do you like to use? And you have the selection, right? And then you have question number 2, why? Okay, now you have question number 2, why? Now, out of the 8, so 8 answered Colgate, the 2 answered a different brand of toothpaste. Now, you look at the answers of the 8 people that chose Colgate to question number 2, which is why. Why do they like Colgate? So one person said it's cheap and affordable. Another person said it my mouth feels refreshed. The other person said my mouth feels clean and refreshed and it is affordable. The other person said because my girlfriend wants me to use Colgate. The other person says I feel I have a fresher breath when I use Colgate. So, see, people have different answers now. So what are you going to do? You get the most common answers, okay? And then you will realize, oh my God, out of the 8 people who said they want to use Colgate, 5 of them gave a reason that they feel that Colgate gives them a fresher breath, a cleaner mouth, cleaner teeth. So this is now the most common reason why people like Colgate. This is the reason why people like Colgate, because this is the most common reasons that the people that I interviewed gave me as an answer. That is what we call qualitative data, again from your descriptive statistics. Okay, very easy. Now, time series data is a collected over a period of time, often comes with intervals. Okay, for example, monthly sales figures, daily sales figures, and even the hourly website traffic data. So again, this is also done from your descriptive statistics, basic statistics that you want to do, but then the only thing that's different is that it gives you numbers, but the numbers are time sensitive. Okay, time sensitive. So what you can do, that is why if you go to the grocery stores, um, they do not hire a cashier that works straight for 12 hours. Or some grocery stores, they do that. But the cashiers will have to remit the money that they keep every 4 hours. Okay? Some of them they remit it after their 8 hour shifts because that is not just for security purposes that you don't keep a lot of money in the till or in the cash box, but it's also a way of identifying which period of time do the cashiers make more money. So if you gave the cashier $100 and after 4 hours, she kept the $100 for the next 4 hours and remitted $800. That means between 9 to, let's just say, for example, 8 a.m. to 12 noon, within that 4 hours, you made a sale of 800. Okay. And then from 12 to 4, the cashier remitted her sales again. But from 12 noon to 4 p.m., she remitted 1,500. Okay, so now you see this is now like a value, a numerical value given to you between time. It's time sensitive, it's time bound. The following day, okay, the cashier again gave you a sales of her sales between 8 a.m. to 12 noon. The amount of money that she gave you was like 600. And then in the afternoon from 12 to 4 p.m., she gave you 1,200. Hmm. So you can now start guessing. I wouldn't say come up with a conclusion. Do not conclude yet because you only have two data, the first day and the second day. You can say that, oh, okay, now, but you can start guessing that the afternoon gives you more sales. Now the third day came in. Third day, 8 a.m. to 12 noon, the cashier gave you $1,000. And then in the afternoon, the cashier also gave you $1,000. So can you say that, oh, the afternoon sales is always more than the morning sales? Okay. You cannot say that because it has the same amount of sales on the third day. So what you're going to do, this is now where the mean median mode standard deviation, variance, the one that I was talking earlier, comes in. Okay, so you add the value of the first day, the second day, and the third day. Okay, so that's 800 plus 600, that's 1,400. And then plus the 1,000 on the third day, that's 2,400. And it's 3 days, right? So you divide it by three. And then by dividing it by three, you can now get the median sale. Like, what's the average sale, the middle sale? So 2,400 divide by 3 days, then that means the average sale or the median sale for 3 straight days is $800 per day. Okay, in the morning. Now in the afternoon, you have 1,500, you have 1,200, and you have 1,000. So again, you add the three. So that will be 1,500 plus 1,200, 2,700 plus 1,000, 3,700. Divide by three. So you are getting 1,233 per day. That's the median sale or the average sale per day, 1,233 per day. Now your morning is 800 per day. That's your average or that's your median sale. Now the afternoon is 1,233 per day. That's your average, that's your median sale. Now you can conclude because you have 3 days of data that the sales in the afternoon is much higher than the sales in the morning. So that means there are more people buying in the afternoon than in the morning. And that is what we call time series data. So see, now you can say, okay, since there are more people buying in the afternoon, what should I do? Maybe in the morning, I will not turn on the air conditioning to cut cost. Anyway, there are fewer people in the morning, lesser people who buy. But since there are more people in the afternoon who buy, I will turn on the AC. Or maybe I will add another cashier so that the payment will be faster. The customers don't have to wait for long lines because I realize that there are more customers in the afternoon buying. Okay, so again, you will find out how to improve your operation, how to improve your customer management because of the data or the statistics or the numbers that are presented to you. Now, measures of central tendency. This is what I explained earlier, the mean, the median, and the mode. Okay, and what we see is the median. What we computed earlier is the median, or what also known as the average. Okay, now, or the middle value. I'm sorry, I made a mistake. What we computed earlier was the mean, which is the average of the data set calculated by summing all values and dividing by the number of values. So sorry, my mistake, my big mistake. I stand to be corrected. It's not called median. It's called mean. The average is called mean. Okay, mean, not median, mean. So being what we computed earlier on the morning sales, which is $800 per day, which is the average sale, that's the mean. Okay, and the computed 1,233.33 sales per day in the afternoon is called the mean. That's the average. So that's the average of data set calculated by summing all values. That means adding all values and dividing them by the number of values. That's what we call the mean. Now, the median is the middle value in a sorted data set, dividing the data into two equal halves. So, how do we compute the middle value or the median? So, for example, for the 3 days, okay, what's the middle value? You have 900, was it 800, 600, and 1,000? Okay, so what are you going to do? You divide the data into two equal halves. Hmm? So again, you add. That's 2,400 divided into two equal halves. Then the median is 1,200, or that's the middle. Now the mode is the most frequently occurring value in the data set. Now we cannot compute the mode for because we only have 3 days of sale. That means we only have 3 days of data. So with that one, and then there are different values. You have 800, 600, and 1000. So there's no such thing as a mode for this data that we provide. Okay, just give me a quick second. I have to charge my laptop because the battery is running low. Okay, here we go. We're back. Now, there's also what we call the measures of dispersion, where there is a range that is the difference between the highest and the lowest values in the data set. So what's the highest value we have? We have 1000 for the morning sales. Okay, we have 800, 600, 1000. And what's the lowest value? 600. So what's the difference between 1000 and 600? That's 400. So the range that we have in our data is 400. Now, standard deviation, that is the square root of the variance, providing a measure of the average deviation from the mean in the original units of measurement. Okay, so therefore, for example, the average deviation from the mean. What is the average deviation from the mean? Um, so you have 800, 600, 1000, and the average, so the mean is 800. Okay, so what's the square root? Oh no, let's discuss first the variance so that you will not be confused. Let's discuss first the variance. So the variance is a measure of how spread out the data is from the mean. So calculated as the average squared deviation from the mean. Okay, so how if it's 800, the other one is just exactly 800. The other one is 600. So therefore, the variance there is 200. The other one is also the other value is 1000. So the distance also from 1000 to the mean is also 800, 200. So therefore, that's your variance, 200. And that's also your standard deviation, 200. Okay, unless because if you divide 200, 200 plus 200 is 4, divide by 2, it's still 200. So that's also your standard deviation, unless if there's a different value of the variance. What if the one variance is like 100, the other variance is 300? So if you add them together, divide by 2, you will have 200 standard deviation. But let's just say the variance, okay, let's use the afternoon values, the afternoon sales as our example. So remember we have 1500, 1200, and 1000. So when you divide them, when you add them, that's 3,700. Divide them by 3. So you have a total mean, and you have a total average of 1,233.33. So what's the difference? What's the variance? Okay, between 1,233 and 1,500. So you have there 267, right? 1,500 is 267. Now, then 1,233 and 1,200, so you have 33. See, there they have different variance. And then you have 1,000 and 1,233, so the difference there is negative 233. So you have different variance. Now, if you're going to do the standard deviation, so the square root of the variance providing a measure of the average deviation from the mean in the original units of measurement. So for example, you add them all together. So you have 233, 33 plus 267. So that's like 266 plus 267. That's 533. 533 divide by 3. is how much? That will be like 150, 190 something. What's the square root of 190? Times 8, no. 10 times 10, 100. That will be like 15 times 15. Let me see. What's the square root of 190? Now I need my calculator. So the square root of 190 is 13.78. So there you go. That's the standard deviation, 13.78. But don't worry about that. We will discuss this clearly later, when we will go to the next weeks. This is just the basic introduction. And then we have probability distributions, okay? We have normal distribution. So as you can see on the screen, it's like a bell shape, it's like a mountain going up and down. That's normal distribution, commonly used to model continuous data characterized by symmetry and a single peak. That means it's balanced. Then you have binomial distribution used to model the probability of success or failure in a fixed number of trials, with each trial having only two possible outcomes, either failure or success. And then you have the Poisson distribution, which models the probability of certain numbers of each in a fixed interval of time and space, assuming, okay, assuming independently and a constant rate. Again, we will discuss that one. And then you have the sampling techniques. You have the simple random sampling, which means each member of the population has an equal chance of being selected because you just randomly choose people. So, for example, simple random sampling. Let's just say, for example, there's 50 people in the classroom, okay? And you want to interview only 35. So you choose 35 people randomly. So that means all the 50 have the chances of being selected to be part of the 35. And all the 50 also have a chance of being not selected and will belong to the 15. Okay, so it's what you call random sampling. Now, stratified sampling, the population is divided into subgroups and a random sample is taken from each group. So for example, there's 50 students in the class, you divide them into 5 groups, so 10 people per groups. Okay, and then you get one, but that is still considered random. How do you call it stratified? Okay, when you say, for example, okay, um, students who are age 10, students who are age 20 to 25, you group them. Students who are boys, you group them. Students who are girls, you group them, and then you get one sample from each. Okay. Now, cluster sampling is also kind of like similar to stratified sampling because the population is divided into clusters and a random sample of clusters is selected. Okay. Now, the difference between this one is because you don't group them into specific groups. Okay. So for stratified sampling, for example, you can say, okay, I will divide the 50 students, boys to my left, girls to my right. Okay, and I will get 10 boys and I will get 10 girls. Okay, so now that's stratified sampling. Or you can say, I want you to divide yourselves into 3 groups: students who are aged 20 to 30, 31 to 40, 41 to 50. And then I will get 2 from each group. That's stratified sampling. Cluster sampling is when you get them into clusters. Okay, so you can say, okay, your cluster, people who can sing, people who can dance, people who can jump, people who can cry and act. And then I will just say, okay, I will just get the people who can sing and dance. So that's cluster sampling. You get the 2 clusters together. You don't get a portion of each group. You just get the cluster. Now, convenience sampling, this is very common in many surveys because you choose individuals who are easily accessible, people whom you have access to, people who easily say yes to join your research, or people who easily say yes, I will answer your questions in your survey. That's those are the different kinds of sampling. This is not descriptive statistics anymore. This is now inferential statistics. Again, what in inferential statistics, you don't interview, you don't include in your survey all the people in the population. You only take a small group of people that can represent the population, and they are called sample. And to choose this sample, there are different techniques. Number one, there's the random technique. Number two, there's a stratified technique. Number three, there's a cluster technique. And number four, the easiest technique, choose whoever is convenient to you, who can meet you up at the time that you want, who is easy and willing to join without any trouble, who is available. That's convenient sampling. But of course, as what I mentioned earlier, when you do sampling, there's always a margin of error because you did not get the answer, you did not get the response of everybody in the population. You're only getting a small group to represent that group, that population. So that means there's always a margin of error. Now, with a different kind of sampling techniques, the margin of error can go higher or lower. Like, for example, in random sampling, the margin of error can be lesser. But in convenient sampling, because you just you just conveniently interview people that is available to you now, or you just conveniently interview people who say yes and agree to join your interview, or you just conveniently interview people who are there where you are right now, then the chances of the margin of error going bigger, and the chances that your answers or numbers are have errors or have mistakes is also higher. Okay. Oh, then we have hypothesis testing. Again, hypothesis is a guess, but it's a good guess, or shall we say a scientific guess. Just like when I gave you the data about the sales in the morning and the sales in the afternoon. So that was not because of the numbers that showed, because when you computed the mean of the 3 day sales is 800 in the morning. The mean of the 3 day sale is 1,233 in the afternoon. That you can say my hypothesis is more people are shopping in the morning. I mean, more people are shopping in the afternoon. That's my hypothesis. That is my scientific guess. Because if why would the sales become bigger in the afternoon? Why would the mean or the average sales is bigger in the afternoon if there are lesser people who will shop? Then that means there are more people who are shopping. That is my hypothesis. Now, to check if my hypothesis is correct, then you do hypothesis testing. And there are different ways to test the hypothesis. You have I mean, this is not the ways. This is the process of testing the hypothesis. Okay. Number one, formulate the hypothesis. We already formulated the hypothesis. We believe that there are more people who are doing shopping in the afternoon based on the numbers and based on the mean of sales that we got in the afternoon. Collect the data. We already collected the data. We get the money or the sales every day for 3 days. And for 3 days, they have different sales amount. But when we computed, okay, the mean or the average sales amount in the afternoon is bigger than the average sales amount in the morning. Then you have your calculate test statistics. Okay, what we just did, that is our calculate test statistics. We computed the mean. Collect the data means collecting the sales, right? So in the morning you have 800, 600, 1000. In the afternoon you have 1500, 1200, and 1000. And then you do the calculate test statistics. For our case of the sales in our grocery store, our test statistics is getting the mean or the average. So adding them together, divide by 3, you got 800 mean or 800 average sales in the morning, and 1,233 sales in the afternoon. So you now have the test statistics. So that means more sales in the afternoon. So that means our guess is that there are more people who are really buying. And then you have determined the p-value. The p-value represents the probability of obtaining the observed results or more results in the null hypothesis were true. Uh-huh. I will explain the determination of p-value in another video because this is also a I mean, even the computation of the mean median mode, I will share it in another video. Even the computation of the standard deviation, I will share it in another video. In the computation of the variance, I will share it in another video because these are complicated ones. Okay. I'm just giving you like a run through of what we are going to be talking about for this entire quarter, this entire academic quarter. And then you make the decision. So you compare the p-value to the significance level of the alpha. Oh my God, this is just so complicated. I will just explain that in a different set of videos. Okay, and then you will have the correlation analysis. Oh, this one. Let's skip to that one. Then you have regression analysis. Let's skip. These are just basic. Okay. Um, so applications of business, let's just go to the applications where you can use your business statistics. So in marketing, of course, you can analyze the customer data, you can predict the sales, and you can evaluate your marketing campaign, whether it's an effective marketing campaign based on the sales that it made, or was it a bad marketing campaign. Finance, you with statistics, you can forecast which months of the year you are going to make a lot of money and which months of the year can be trouble for you. Okay, in that way you can manage the risk and make investment decisions that are really good. So you don't invest at this time of the year when sales and when income or when profit is really low. Operations, of course, you can predict how many people you need. You can predict what hours should they be working, what day you need more staff. Okay, especially when it comes to the supply chain efficiency, like how many products you need to supply the demand, and then even in human resource, you can use business statistics to check the performance of your employee. Are they meeting their KPIs? Are they meeting what is expected from them? Are they performing very well? You can use statistics. So, conclusion and key takeaways. Business statistics is an indispensable tool for organizations striving to make data driven decisions, understand market trends, and improve operational efficiency. By applying statistical methods, businesses can gain valuable insights, m- lower down or mitigate risks, and achieve sustainable growth. Remember to always consider the context of your data and ensure your analysis are accurate and relevant. Okay. Supposedly, this week's lecture, the first week's lecture, I would have not discussed in details all those things. I am just giving you like a a patch on the shoulder or a tap on the shoulder of what are we going to be talking about for this entire quarter. So, but I believe I've already talked about mean, median, and mode. But again, it needs a separate video for that one. Um, Also, the variance, computations of variance and standard deviation, even the sampling techniques, even the testing of hypothesis, and then also the analysis of your hypothesis. Oh my God. Those are to be discussed differently in a separate video. So don't overwhelm yourself with all these information. All I just want you to do is look at the look at the readings and watch the videos and have fun. Okay? So thank you very much, and I'll see you all next week. Have a great day. Bye bye.